So in the last video, we discussed a formula that had two applications. Here we're going to look at another like that, but we've already discussed one of the applications back in compound interest. So with compound interest, what did we do? We made a deposit and we looked at what it was worth in the future, given a bunch of other information. Well, we can flip that around to get something called the present value. And for that, what we're going to do is figure out some future amount and backtrack that to today. So say in the future you want a certain amount in an account. Well, what lump deposit would I need to make now that'll give me that? This is similar to the payment formula, except we're not going to be having, well, it is similar to what we wanted with the payment formula, but we're not going to make monthly deposits here. We're just going to make one initial deposit. Well, let's define that and then discuss the formula. So definition. The present value of an amount to be paid in the future is what that future amount is worth today, determined by the interest rate. So we want, we are at today, and we're thinking, well, I want $1 million in 10 years. Here's an account. What do I need to put in there today to get $1 million? Well, you can see that that is the backwards way of asking our compound interest formula, which say, I want to make a deposit now. How does that grow? So in the compound interest application, our variable in question was the future amount, given a today amount. Here, our variable in question is what do I need to deposit today in order to get some future amount. And yes, and this does differ from payment, what we did with payment, because with payment, we were looking at a periodic deposit. Here, we're just looking at one deposit. So I'll say to find the present value formula, we solve the compound interest formula for P. So let's write it down. I'll write it like this: present value formula. Now that was a couple weeks ago. Well, I guess it was last week. So I'll redefine the variables here. The present value UE P of an amount A to be paid T years in the future, earning in the meantime, meantime might be two words, interest at annual rate R compounded M times per year is, well, solve it for P, solve the compound interest formula for P, and you get P equals A over 1 plus R over M to the MT. So again, with this one, I am just going to leave it as with the annual rate. You could change it to INN if you want, but I'm gonna, the periodic rate. I'm just gonna leave it as the annual rate. And let's just look at an example of this. Example: how much should you deposit into an account earning interest at 0.747% annually, compounding or compounded daily? Let's spell daily properly. So how much should you deposit into an account earning interest at this rate, compounded daily, in order to have $12,000 in 60 months? So how much you deposit into an account earning interest at that annual rate, compounded daily, in order to have this amount in 60 months? Well, we are going to need to do a little bit of unit conversions, because the form, you could use the formula with the periodic rate and convert everything to, in that case, days. I'm going to convert the months into years and apply the formula directly. So here, P would equal what? The amount we want, 12,000, divided by what? 1 plus 0.00747, divided into our number of compounding periods per year, daily compounding, 365 compounding periods in a year. And then we're going to raise this denominator to the number of compounding periods in the year. So 365 times the number of years, 60 months, is 5 years. And this is approximately equal to 1,560. Oh, sorry, I missed a 1. 1,560 and 7 cents. And this answer does make sense because it is a very low interest rate. So, in 5 years, it is only earning $440, which is not that much. And with this, you could play around with rates, a little more than we did with payment and savings formula. So there will be some like that on the